So in this lesson, we are going to learn how to form a differential equation using the method of elimination of arbitrary constants. Now let's assume that we are given a function y equals c1 sine x plus c2 cos x, where c1 and c2 are arbitrary constants. Now we want to form a differential equation by removing or eliminating these arbitrary constants. Now to do so, you realize that once we have two arbitrary constants, then it means that the differential equation we are going to obtain is a second order differential equation, and hence it means that we are going to differentiate this function two times. So first we have y prime, and that is equal to c1 is a constant, so we have c1, and then we differentiate sine x, and that gives us cos x, so we have c1 cos x. Now whenever you differentiate cos x, you have negative sine x, so it becomes negative c2 sine x. First, let's call this equation 1, let's call this equation 2. Now to y prime prime, that will be equal to, when you differentiate cos x, you have negative sine x, so it becomes negative c1 sine x. When you differentiate sine x, you have cos x, so it still remains negative, and then you have c2 cos x. Let's call this equation 3. Now let's compare any two equations at a time. So let's compare equation 1 and 2. For equation 1, we have here to be sine x, this is cos x, we have cos x, and this is also sine x. Now let's compare equation 1 and then 3. We have sine x, cos x, cos x. So you realize that this equation 1, looks like equation 3. Now for equation 1 to perfectly look like equation 3, we need to adjust it. So what we are going to do is, from equation 3, we can represent equation 3 as y prime prime equals, we factor out negative 1, so negative 1, and then inside of the bracket we have c1 sine x plus c2 cos x. And you realize that what we have in the bracket is what we have as y for equation 1. So we are going to put equation 1 in here. So that becomes y prime prime equals negative 1 times y, and that is equal to negative y. So we transpose negative y to the left hand side, and then we have y prime prime plus y equals 0, and that is the square y over the x square plus y equals 0. So at this point, we've been able to form the differential equation eliminating the arbitrary constants c1 and c2. So this is a second order differential equation. This is a second order differential equation. Now one important thing you need to understand is there are so many methods in forming a differential equation by removing or eliminating arbitrary constants. And one method which may be efficient for a particular question may be poor for another. And so you may need to practice more in order to familiarize yourself with each of the methods and to know the appropriate method to use for a particular problem. Now we are going to consider the second example while we use a different approach in solving or in forming the differential equation. So let's do that. So for example 2, given the function y equals c1 times e to the power negative 2x plus c2 times e to the power 3x, where c1 and c2 are arbitrary constants. Let's try to find or form the differential equation removing c1 and c2. So we call this equation 1, we have two arbitrary constants, second order differential equation, so we are going to differentiate 2 times. So we have y prime to be equal to, c1 is a constant, okay, so you want to differentiate e to the power negative 2x, so you are going to differentiate the exponent, that will give negative 2, and then you multiply that by e to the power negative 2x, so e to the power negative 2x, so times c1, and then plus, you do same for the other term, so you are going to have 3 when you differentiate this times e to the power 3x times c2. Let's call this equation 2. For y prime prime, that will be equal to, you differentiate this, you have negative 2 times negative 2 is 4, so 4 e to the power negative 2x times c1, plus you differentiate 3x, you have 3, so 3 times 3 is 9 e to the power 3x times c2. Let's call this equation 3. Now, instead of using the approach or the method in example 1, we are going to use the matrix form. So we are going to construct a 3 by 3 determinant to find the differential equation. So we have a 3 by 3 matrix, and then inside of the matrix, for row 1, we are going to have y. Now you realize that we have arbitrary constants c1 and c2, and the whole idea is to remove those arbitrary constants, so we don't think of including them in this 3 by 3 matrix or 3 by 3 determinant. However, let's also consider e to the power negative 2x. You realize that it is common to all the arbitrary constants in the second column. Okay, it is common in the second column, and then we have e to the power 3x also common in the third column. So we are not going to include e to the power negative 2x and e to the power 3x. Again, we are going to transpose all the terms we have on the right hand side to the left hand side, okay, so that we have that equated to 0. So if y is on the left hand side already, and then we want to transpose this to the left hand side, notice that we are not going to include e to the power negative 2x, neither are we going to include c1. Hence, it means what we have here is actually 1. So we are going to transpose this 1 to the left hand side, so it becomes negative 1. And the same happens to this. We have 1 here, so we are going to transpose that to the left hand side, it becomes negative 1. Now, for the second row, we are going to have y prime. Here we have negative 2, so we transpose that here, it becomes plus 2. Here we have 3, we transpose to the left hand side, we have negative 3. For row 3, we have y prime prime, and then negative 4, negative 9. So let's try to find the determinant. So we select this value, we cancel out the row and column containing this value, and then we multiply negative 9 by 2, that is negative 18, minus negative 4 times negative 3, that is 12. So minus 12, minus, we select this value, we cancel out the row and column containing this value. So negative 9 times y prime, that will be negative 9 y prime, minus y prime prime times negative 3, that will be negative 3 y prime prime, so it becomes plus 3 y prime prime, and then plus negative 1, we cancel out row and column containing negative 1, negative 4 times y prime, that is negative 4 y prime, and then y prime prime times 2, so we have minus y prime prime times 2, that is 2y prime prime, and that is equal to 0. Let's simplify. So we are going to have negative 18 minus 12 is negative 30, so negative 30 y, this becomes plus, so 1 times negative 9 y prime, it becomes negative 9 y prime, and then plus 3 y prime prime. Here we have negative 1, negative negative becomes positive, so plus 4y prime, and then here we have negative negative positive plus 2y prime prime equals 0. Let's simplify further. So we are going to have negative 30y. Here we have y prime. So negative 9 plus 4 is negative 5 y prime. 3 plus 2 is 5 y prime prime equals 0. Now we can divide through by negative 5, or better still by 5. So if you divide through by 5, then we have negative 6y minus y prime plus y prime prime equals 0. So we can further represent this as y prime prime minus y prime minus 6y equals 0. So this is the differential equation after removing C1 and C2. Now let's move on as we solve some more complex examples. Now to example 3, we are going to form the differential equation for y equals e to the power negative 2x times a plus b x all in a bracket. So let's solve this together. So we have two arbitrary constants. It means that we are going to differentiate y 2 times. So we have y to be equal to e to the power negative 2x times a plus bx. So for y prime, that will be equal to, we are going to use the product rule. So we hold e to the power negative 2x and we try to differentiate this. So when you differentiate a, which is a constant, you have 0. When you differentiate bx, you have b, plus you hold a plus bx and you try to differentiate this. So you differentiate the exponent, you have negative 2 and then e to the power negative 2x. Now let's simplify this. So this is equal to, you have b e to the power negative 2x, and then you pull out negative 2, so minus 2 into bracket a plus bx times e to the power negative 2x. So that is y prime. So let's call this equation 1 and let's call this equation 2. Now you realize that y is equal to e to the power negative 2x times a plus bx, and that is exactly what we have here. And so we can substitute equation 1 into equation 2. So we put equation 1 into equation 2. So that will be y prime equals b times e to the power negative 2x minus 2, and then we have y. So we've succeeded in eliminating a. Now let's work on eliminating b. Now let's find y prime prime. So we have y prime prime equals, we differentiate negative 2x, so we have negative 2 times b times e to the power negative 2x minus, now this is a constant, so 2 minus 2. Now when you differentiate y with respect to x, you have dy dx, or better still y prime. So that is y prime. Now at this point, you realize that we have b times e to the power negative 2x. Now let's look at equation 2. You realize that we have b times e to the power negative 2x. So let's make b times e to the power negative 2x the subject from equation 2. So even before that, we have this to be equation 3. So we make we make b e to the power negative 2x the subject from equation 2. So that would be y prime, we transpose this to the left hand side, plus 2 into bracket a plus bx times e to the power negative 2x. That's equal to b times e to the power negative 2x. So we call this equation 4. Next, we are going to put equation 4 into equation 3. So we put equation 4 into equation 3. So for equation 3, that's going to be y prime prime equals negative 2 into bracket y prime plus 2 times a plus b x e to the power negative 2x, and then minus 2y prime. So let's simplify further. Now remember that a plus b x all in a bracket times e to the power negative 2x is equal to y. So you are going to have negative 2 into bracket y prime plus 2y minus 2y prime. So this becomes negative 2y prime minus 4y minus 2y prime equals y prime prime. And then let's transpose all of this to the left hand side. Even before that, we have negative 2y prime minus 2y prime. That becomes negative 4y prime. So you transpose that to the left hand side, it becomes positive. So positive 4y prime. And then also we transpose negative 4y to the left hand side, we have plus 4y equals 0. Therefore we have this to be the differential equation after eliminating a and b. So that is y prime prime plus 4y prime plus 4y equals 0. So let's solve the last example for today's lesson. We are going to form the differential equation for the given function y equals a times x minus 1, or divided by x plus 1. Let's try this together. So here we have only one arbitrary constant, that is a. So we are going to do only one differentiation. So we have y giving us a times x minus 1, or divided by x plus 1. Now this function is given of the form y equals u times v. So if you want to find the y dx, then that's basically you hold v, you differentiate u with respect to x, minus you hold u, you differentiate v with respect to x, all divided by v square. So that's what we are going to do. So even before that, you need to factor out a. So you have a, and then you have x minus 1. So a on the outside, x minus 1 divided by x plus 1. So x minus 1 is u, x plus 1 is v. So let's find the y dx. So that will be equal to, we have a on the outside, and then you are going to hold v. So that is x plus 1, and then you differentiate u with respect to x. So when you differentiate x, you have 1. When you differentiate negative 1, which is a constant, you have 0, minus u, which is x minus 1. When you differentiate x plus 1, you have 1, all divided by x plus 1 all square. Now let's simplify. So you have x plus 1. Now 1 times x minus 1 is the same as x minus 1. So this negative is going to affect each of the terms. So you have negative x plus 1. So negative is positive, divided by x plus 1 all square. That is equal to x cancels out negative x. We are left with 1 plus 1, which is 2. So 2 over x plus 1 all square. So we have times a. So that is dy dx. So dy dx is equal to 2a over x plus 1 all square. Now let's call this equation 1. Let's call this equation 2. Now from equation 1, we can make a the subject. We can make a the subject from equation 1. So make a the subject from equation 1. So we are going to cross multiply. So that's, you have y times x plus 1 equals a into bracket x minus 1. You divide through by x minus 1, x minus 1, and then you have a to be equal to y times x plus 1 over x minus 1. Now let's call this equation 3. So next, what's going to happen is we are going to put equation 3 into equation 2. You are going to put equation 3 into equation 2. So that's, you have dy dx equals 2 times a. So 2 times y times x plus 1 in the bracket divided by x minus 1, or divided by x plus 1 all square. Now let's further simplify this. So this will be equal to, you have 2y times x plus 1 all divided by x minus 1, and this denominator becomes, you have x plus 1 all square divided by 1. So it becomes 1 over, when you want to multiply by the reciprocal of this, so 1 over x plus 1 all square. So x plus 1 cancels 1 of the x plus 1, and then you are left with 2y over x minus 1 x plus 1. Now x minus 1 x plus 1 can be simplified as, you multiply x by x, you have x squared, negative x, or better still, negative 1 times x is negative x, x times 1 is x, negative 1 times 1 is negative 1. So this cancels out this, you are left with x squared minus 1. So that will be equal to 2y over x squared minus 1. And don't forget, that is equal to dy dx. So this is where we've got into. Now you can rewrite dy dx as y prime, so that you have 2y over x squared minus 1 equals y prime. So you cross multiply, and then you have 2y equals y prime times x squared minus 1, and that's y prime times x squared minus 1. You transpose this to the right hand side, it becomes negative 2y equals 0. Therefore this is the differential equation after eliminating the arbitrary constant a. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.